Hello, everybody. I wanted to welcome all of you to our Code Labs Tech Talk today. I'm super excited to have everybody here. I want to welcome Adwait, who is the founder of DataSeers and is going to be talking about data science today.
Hey guys, hope you can hear me.
Yes,
my
we
name
can.
is Adwait Joshi, and I'm going to briefly talk to you guys about what we do and how we use data science to solve some real world problems. So let me share my screen. All right, so like I said, my name is Adwait and I'm the Chief Seer at DataSeers. Actually, as of this month, there is a star out there in the galaxy somewhere with the name of Chief Seer. So, you guys can actually stare at the sky and say, you saw Chief Seer. So what do we do exactly when I say that we are taming the data demon? If you look at the biggest problem the industry has today, people talk about siloed data. So data is sitting in a lot of different crooks and corners and nooks, and it's unusable because it may sit in a legacy database. Nobody understands the structure that the developer has left, and it sits somewhere in a file on some old file system or somebody's computer, et cetera, et cetera, et cetera. Usually, data is also unclean. You can't just take data, run it through a magical algorithm and get answers, right? I always say this, that AI does not solve problems, data does, right? So unclean data is absolutely unusable, right? And what happens as a result of that unusable data is it gives rise to a massive problem that a lot of people face today. So I work in the financial services industry. Our company focuses on fraud and compliance. We are trying to find patterns in data that look like suspicious. It could lead to many, many, many different types of frauds on our platform. So if you don't use your data, if your data is unclean and unusable, it generally translates 1:1 to fines. If you go online and look at many different banks and just Google your favorite bank followed by the word fine, you'll see how much money has been fined, right? They have paid in fines for not having a good money laundering solution, anti-money laundering solution, not having a good system for UDAP, and so on and so forth. So that's really, it's a 1:1. You don't use your data, you're going to get into trouble. So I started this company 3 years ago with the focus of solving the 4V problem. And what is the 4V problem? So data is being created in large volumes, right? So if you look at the current metric, there is some 2.4 quintillion bytes of data that's created, right? All the time. Velocity, as payments becomes faster, you're able to pay people quickly. Most of these systems are putting pressure on the existing payment trails. And so the data is also coming in fast and at a very high volume. Variety. There's different forms of payments. You can pay somebody cash, you can pay somebody with your card, you can use Venmo, you can use Square Cash, you can use Chime, you can use Revolut. I mean, pick your poison. There is a million different ways of transferring money from one another these days. So what happens for a person who is looking at it from a back end perspective, which is generally the bank, they lack veracity. They have so many different systems that are siloed. They have so many different systems that are completely different from each other. It becomes really, really, really difficult to make sense of all of that, right? So traditionally, people have used legacy systems, right? Banks still use mainframes, and that happens to be one of the biggest piece of technologies that most banks have, right? So they have legacy systems. They're used to legacy systems. And what happens as a result of that is they're very, very, very slow. Takes a lot of time to analyze that data, get something meaningful out there. And most of the times they are erroneous. So you end up having a lot of data problems. So what is the effect of that, right? the effect of that is information noise, right? So you create too much information that is sent to the end user, who obviously eventually gets overwhelmed, and they have no idea what to do with that information, which clearly gives rise to fraud. Um, People are looking for opportunities where I'm going to bombard you with so much information that you're not going to be able to catch me. That's actually a very classic mechanism of an attack. If you're familiar with how DDoS attacks work, that's exactly what they do. They send you hundreds of thousands and millions of requests, and they just overwhelm the system so much that you cannot isolate good traffic and bad traffic, and as a result, your entire system ends up coming down. That's the same technique that's been used by people who are committing financial fraud all over the place, right? And that gives rise to frustration, because as fraud increases, somebody is losing their job at the bank or at a financial services company because they're simply not doing a good job to protect the bank or the financial institution, and not doing a good job to stop this fraud from happening. But it's beyond their control, because there's so much information, so many different systems to look through, trying to figure out, and they're moving at such a high speed, you cannot keep up. It just ends up being a big mess. So how do you solve it? So we have created a platform that sits on top of HPCC Systems. I think you guys must have had a session with Arjuna earlier today, where he spoke about HPCC Systems and how it works. So we have used our entire platform to basically, or rather, we have designed our entire platform to use HPCC Systems. That is our primary database of record, you may call it, or system of record, you may call it. The system keeps track of everything that is happening. So how do we do that, right? So we ingest real-time data, we ingest batch data, we ingest structured data, we ingest unstructured data, we ingest public data, we ingest private data. So we have data coming in from all over the place, right? So we do not have a single source. At this point, we have hundreds of data sources where we are getting data from. And what happens is this data comes in and it passes through what we call as Seers. So each Seer has a specific task. Seer is nothing but somebody who sees, right? Somebody who has a vision. In our case, a Seer, somebody oversees a process. So we have a file Seer. The job of a file Seer is to quickly identify the file, what is in the file, how important it is, what happens, et cetera, and then ingest that data in, homogenize it securely, of course, and be able to use that information. Similarly, we have message Seer. The job of a message Seer is able to ingest real-time messages. Now, these real-time messages can be in any format. They can be XML, they can be JSON, they even can be traditional financial services messages like 8583 or 20022. They could be Swift messages. There is so many different types of information that is flowing through the system at any given point of time. So we don't care. We ingest whatever message comes to us, right? So we have an API endpoint, and it comes in, gets ingested into HPCC Systems. So we have a data pipeline, a single data pipeline. In that single data pipeline, we have identified how the messages come in and how the files come in, and how all of those or all of that data eventually combines together and people derive value from it. So once the data is all ingested, it sits in a Data Vault 2.0 architecture. Not sure if you guys know what Data Vault means, so I'll explain. When database concepts came out, everybody was using databases, traditional databases. When traditional databases became too slow to do analytics, people started coming up with analytical databases or data warehouses. When data warehouses became old and clunky and difficult to maintain and started to introduce more unstructured data, people started talking about data lakes. When data lakes came on and people started dumping all of this information, the biggest question and the biggest challenge came on is, okay, I need to understand how the data came in, where it came in from, was it good, was it bad, who gave it, who is using it, et cetera, et cetera, et cetera. And those concepts did not traditionally exist in the data lake world. So the concept of a data vault came in. If you're going inside a vault, you need a key to go inside a vault. Typically, when you access some sort of a vault, you have to have an audit log. Somebody asks you, hey, where are you going? Can you please fill out your information? Can you give me your name, your driver's license, all of that, right? So there is a bit of authentication, authorization, as well as auditing that happens in a data vault. And so Data Vault 2.0 is the second generation concept of a data vault where things are kept in lock and key. And it's almost like, you can almost call it like a blockchain, but it's not, where you can go back to the original source and identify where that piece of information came from. Was it good? Was it bad? When did it come? How did it get ingested, et cetera, et cetera, et cetera. It's very important because if you're going to use data as a decisioning point, you want to make sure you track your sources and they're trusted for, and so on and so forth. After the data comes into our Data Vault 2.0 architecture, which of course in this case is HPCC Systems, we then run 4 more Seers on top of it. One is Compliance Seer, one is Recon Seer, one is Fraud Seer, and the last one is Strata Seer. And the application, the entire product application that contains all these Seers is called as FinanSeer. It's nothing but, the way we put it, is an artificially intelligent appliance for banking and payments. And what we have really done here is we have taken the guesswork out of this entire appliance. It almost works like a black box, almost like magic, where data comes in, the systems do its job, and it tells you, okay, here is a problem. How it ends up finding the problem is the key. That's where our IP sits. If you notice, I'll explain to you a little bit of each of these Seers and how does machine learning and AI come into play. Compliance Seer. So we are looking for compliance issues. So as you know, in at least in the US, since most of you guys, I'm assuming, are from the US, is that right? Cora, I think.
Yes, a lot of our students are from the US, but we do have students who are international as well.
All right, so I'll give you guys some examples pertaining to the US as well as international. So when you talk about compliance, there are certain things that you have to do as far as compliance goes. So most of the people on this webinar know what happened on 9/11. After 9/11 took place, the US passed Patriot Act, which means that every single bank that was working or that is working, or every single financial institution that is working with an individual, is now required by law to verify that their information is checked against regular sources, right, or standard traditional sources. So the parent company of HPCC Systems, which is LexisNexis, has a group called LexisNexis Risk Solutions. And that is a classic example that if you went and you opened up a bank account, or if you went and if you try to download Cash App or Venmo and try to get an account, your information is going to be validated against a database like LexisNexis is before any decision is made to give you an account or not, right? So that is Patriot Act. Then it goes further beyond that, and you start checking sanctions lists. So in the US, we have a list called OFAC. And most people, most terrorists, wanted criminals, drug criminals appear on this list. Similarly, in the rest of the world, they have a sanctions list. Those sanctions can be US sanctions. They could be issued by FATF countries, financial task force countries. And so what happens, and what you have to do is you have to take the information that is provided to you, in which case, most of the cases, it is a first name, a last known address, a maybe a known country of origin or birth, a close enough date of birth, and some other information that they have on these people. And you're supposed to match it against that and make sure that these guys do not exist on that list, right? So that is where a classic machine learning or AI experience begins, because what you're typically doing is you're looking at all these entities, you're looking at the information that you have been provided by your end client. So John Doe goes in, John Doe types his name, address, and social security number, and so on and so forth. I take John Doe's information, and then I run a name matching and a information matching algorithm to try and see if John Doe exists on any of these lists. It's required by law. So by that law going into place, right, was the first exposure of how machine learning and AI had to be used to do that. Because take my name, for example, right? Adwait Joshi. It's not a common American name. You can name it however, you can spell it however you want. You can spell it with ADWAIT. You can spell it with ADVAIT. You can add an H in the end. There's so many variations. Similarly, in the US, right, we have so many nicknames. You know, Robert can go by Bob. You know, Jonathan can go by John, and John could be spelled Jon. John could be spelled John. So there is a lot of different variations. So if John is applying for a car and on a sanctions list there is a Jonathan, it is my job to make sure that that Jonathan on that list and the John that's applying with me is not the same guy. So you have to use a lot of these algorithms that are out of the box to kind of identify and put a score together to figure out whether or not this person is who he is. So that's where it begins. Then you go through a lot of these compliance requirements, right? So if you ever went to a bank and deposited more than $10,000 in cash, they would ask you to file a CTR, currency transmission report. I mean, it's required by FinCEN, which is the Financial Crimes Enforcement Network, because they want to track illegal money coming in and out. So there are scenarios where people apply these algorithms in money laundering. There has to be a process, and there is in a bank. I mean, you have to have a process in a bank in order to track for these things. If you don't, you're getting into some serious trouble and you're paying fines. And those fines are not small. They're not 20 bucks. They're not 50 bucks. You're talking about 300 million, 500 million, $2 billion fines, right? And there is a lot of these problems happen because things are not looked at correctly. Then you have other compliance where you have to match for a behavior or a pattern that a financial institution may exhibit, where they are abusing the terms and conditions that they have set forth for their customers. So if you looked at the news and Googled Wells Fargo UDAP violations, it'll show up that how they violated those UDAP rules and got fined, I think, $2 billion, right? And $2 billion is a lot of money. So some of these things are patterns. They're patterns that you can recognize through data. They're patterns that you can recognize through algorithms and so on and so forth. Then comes the reconciliation piece. Reconciliation usually means understanding money movement, understanding the timing of that money movement. I'm pretty sure you guys, all of you guys use some or the other bank account, right? Or a bank-like account where you get money as a check, or you deposit money as an ACH or a wire transfer or something. And you notice that when the money comes in, it doesn't get posted immediately. It shows it's pending, and it's posted at the end of the day as a batch. Most banks, like I said earlier, have legacy systems, old systems that are clunky. This is one of them. The world is now starting to move towards more near time before they get to real time reconciliation. The Federal Reserve is talking about adding more timings for ACH processing. Today they process it 3 times a day. They're adding a 4th. They could add a 5th. There is also companies that do same day ACH processing. As soon as you start increasing the timing and the speed of these payments, reconciliation becomes a crazy thing. Most of the times when you try to reconcile payments, what you're trying to do is, to explain it simply, you're comparing 2 databases at some point of time, right? You're comparing a database on the left, you're comparing a database on the right, or a table on the left and a table on the right, and you're trying to figure out which match and what doesn't match. Except, your join conditions are not as simple as left dot element 1 equal to right dot element 1. You can't do that because sometimes you have data on the left hand side but not on the right hand side. And I'm saying not the entire row missing, but I'm saying there are holes in the data. Sometimes you don't have the information to match. And so you need to start using algorithms that actually tell you with confidence that this entry on the left hand side and this entry on the right hand side is actually belonging to the same transaction, although it doesn't look like it, right? And that's when you join it, and that's when you actually reconcile those transactions. So machine learning and AI doesn't just need to be used in fraud when it comes to traditional payments and banking, right? So far, compliance is compliance. It's not fraud. Reconciliation is reconciliation. It's not fraud. So now that brings us to the fraud. Of course, we are going to use machine learning and AI for fraud. So, there's many different use cases. I have a slide later that I'm going to talk about what are the different use cases that we use. But one of the simplest things that is in the news today, right, or has been in the news is Ghislaine Maxwell and Epstein and all the human trafficking that has been happening around in the world, right? So that's a classic example of fraud where you could look for certain patterns if you have good enough data and identify those things within data and then report them to the authorities. And then last but not the least, AI is also important when it comes to analytics. StrataSeer in our system is nothing but it's an engine of multiple layers of analytics. What that means is I'm able to figure out what is the consumer actually going to do next. So I can tell you that, okay, he's going to go to Starbucks tomorrow to buy something because that's his typical pattern. Tomorrow happens to be Thursday. Every Thursday, John Doe goes to Starbucks and buys something. Tomorrow he's going to go there, right? So you can do that. You can say, okay, when is an individual going to close an account? So you're talking about churn analytics. You can do segmentation, trying to figure out which of my consumers are giving me the most money with the least push, which ones are not giving me enough money, whom can I push, et cetera, et cetera, et cetera. So all of these four fields of work for us, which are four major verticals within a financial institution, which is compliance, fraud, reconciliation, and treasury is the other word for it, and analytics, which is generally driven by marketing, come into play for us in the same platform using the same piece of technology, which is HPCC Systems. Then we also go a little bit further and we provide a nice UI dashboard for our consumers so that they can pull this data out, they can look at different things and so on and so forth. And what we use for that is Elasticsearch and Kibana, because it's very good at extracting that data out, and it gives you a nice visual UI to do everything. So as you can see, we are relying on data a lot, right? A lot. If you guys rely on a car to go from your house to your college or from your house to the grocery store, you're going to make sure that the check engine light is not on, right? You're going to make sure you have a driver's license. You're going to make sure that the car has gas. You're going to make sure that the tires have air. They're not flat. Just like how you do those checks, basic checks. Some you do every day, some you do once a month, some you do once a year. We do the same kind of checks on our data. So there we go. It's called as data governance, right? I've said this earlier, AI doesn't solve problems, data does. You can have the most fancy algorithms that you have written, and they will do nothing and nothing at all until you have data to feed through it, right? So it's like you have these amazing chef utensils and you have these amazing sets of knives that you're dying to use, but you don't have meat or you don't have vegetables to cut. What are you going to do? Nothing. It's the same way. So in data governance, it's very important to make sure that if you are relying on data, your SLAs are being met. What does that mean? If my algorithm expects fresh data every day, then I want to make sure that I get fresh data every day, right? It's almost like running a kitchen. I wake up, I make sure that I have all the vegetables, I chop them up, I load them, I keep them ready whenever I want to do what I want to do. So same way, when I wake up or when the machines wake up, they make sure that they have all the data. If they don't have the data, they're going to complain, so on and so forth. Similarly, you have to have data quality checks. You can have the best algorithm in the world and I can run junk data through it and it won't do anything. It will fail. So you have to make sure your data is good. Then we do data profiling. So I have made sure that I got the data, everything looks okay. So now let me start on, going through a little bit more in detail and see what what is there in that data. So I'm start uncovering cardinality and important information about that data. Now, just because data profiling was not enough once, it's 2 times, right? You have to do your data profiling. If you do not do your data profiling, just stop working, go take another job. If you do not do these pieces, you cannot solve your problems. At this point, data should not be run through any of it. So most important part of any data science exercise is to understand your data and understand the domain. So let's look at what do we do. So we collect data from, like I said, all different types of sources. We bring it in and we homogenize all of this data. We actually run it through a proprietary process, which is patent pending, called as cleaning, homogenization, ingestion, labeling, and augmentation. A lot of times, I do not have the data to make a decision. So I may get a request that says, this person is trying to do this transaction. And I cannot tell you if it is fraud or if it is not fraud. Why? Because I don't have enough information to make the decision. So what do? We have the ability to augment data from a multitude of third-party data sources. We can bring that information in when we need it, how we need it, in order to make that decision at that point of time, right? So that's the data augmentation. And of course, because HPCC Systems is a distributed engine, we distribute the data. Then we use a combination of AI algorithms, machine learning algorithms, and we come up with scores and results. And the accuracy is much, much, much higher than the traditional systems because we have made sure that this data pipeline is very clean. It's the same example. I mean, if you live in Atlanta, and if you just open your tap, pour water in a glass and drink, it's going to have a lot of crap in it, right? A lot of it. So you're going to have to run it through a filter, a water filter that cleans that water, makes it palatable, makes sure that it's safe for you to eat, drink, and so on and so forth, or cook with, because we have seen many times, how many times the Atlanta restaurants get shut down because a pipe gets busted, right? And they can't serve food. Same thing happens here. You get crap data, you shouldn't be serving it to your algorithms, right? So that's the whole concept of a data pipeline and making sure things are done right. So we already spoke about our 4 Seers: compliance Seer, recon Seer, fraud Seer, and strata Seer. All those 4 Seers have their own job. They share information with each other. They use different types of algorithms and so on and so forth. So let's look into what type of algorithms they actually use, right? So very first thing we look for is identity theft, right? So as you guys know, it's very common in the industry today to have your identity stolen. Why? Because this data has been hacked. It has been hijacked. It has been used everywhere. You can go on dark web and buy people's social security numbers, date of births, driver's license numbers for probably a penny. And you can buy them in bulk. And they will also tell you that this information was last verified 5 minutes ago. So getting your information these days is not hard. So we got to make sure we use algorithms on our side. And that's pretty much one of the biggest things that LexisNexis does is trying to find out, information on people, right? We do the same thing. So that's why it's a great partnership. And both of us use HPCC systems, right? At the end of the day, we look for patterns like money laundering. If you look at a traditional money laundering example, money laundering is nothing but introduction of cash into the digital market and layering it out and spreading it out. So I will give you an example. You just walked up with 2 suitcases of cash into a bank, and you basically gave them those 2 suitcases of cash, and let's just make it up. Each one had $1 million in cash in it. What do you think the bank's going to do? That's an open question to all of you guys. If you want to type the answer in the chat window so that I know that you're not asleep and you're participating, what do you think that these people will do, the bank will do, if you brought 2 suitcases of $1 million cash each? I'll give you guys like 30 seconds to answer. I don't know if, Cora, they can answer or they cannot answer or what, but I hope they can.
So they can.
Oh, there we go. There is a chat. There we go. So they would say a bank would use the silent alarm. All right. So that's what that came from Raymond Wu. Does it? They don't keep it in that branch. Okay. That's what Lila says. They won't keep it in that branch. Anything? Anybody else has any other answers? All right. So I will tell you, the good news is they would do neither of it. They would actually will be forced to take the money from you. They will not press the silent alarm. It's not their job to know if you legally or illegally obtained that cash. That's not their job. They're not law enforcement. However, what they will do is they will ask you where the money came from. And if you said that the money was just hiding in the wall in my house, and I just took down the wall, and my great grandpa had hidden a treasure and I found it, and that's what it is, then they will have to accept that story as well as the cash. But they will ask you to fill a CTR. A CTR is a currency transmission report. You will fill out the form. You'll basically check the box. You'll say where the money came from, and that report will go to FinCEN. And then it's up to law enforcement to decide whether they buy your explanation or they don't buy your explanation. However, that's how most fraud takes place. Is most people use cash because cash is untraceable, right? So most of the money laundering takes place because of cash or starts with cash. President Nixon introduced the BSA Act, Bank Secrecy Act, where the bank would secretly report you or suspicious activity to the FinCEN after they found that Pablo Escobar was flying in planes of cash money into this country and depositing it into banks. So that's where the whole BSA Act came into play, is because they wanted to curb the drug traffickers from bringing in cash. So what do they do now? Well, they come up with new techniques. If you guys have not watched the show on Netflix called Ozark, you should watch it, because that's a classic study. It's actually, it should be a course in money laundering. If you're fighting money laundering, you need to understand how money is laundered. They have 3 seasons of Ozark on Netflix, and they systematically show how money is laundered today in this country. So we look for patterns like that. We look for activity like that, and we try to block it. We try to identify it so that the banks can then press the silent alarm. And their way of pressing the silent alarm is reporting something that is suspicious to the authorities. And then the authorities figure out what to do with it. Next comes drug trafficking, right? So yes, you can go after the big guys if you follow the money trail, but you can also go after the small guys, the guys that are working the streets from a drug trafficking perspective. Because these days what happens is, back in the day, if you were selling drugs to somebody on the street, you might take 20 bucks, 50 bucks, 100 bucks, and so on and so forth. But today, these guys are using P2P transfers. They're using PayPal, they're using a Cash App, they're using Venmo, they're using these other digital mechanisms to transfer money. Not because those applications allow you to do that, Oh, no, no, no. Those applications are phenomenal. They have amazing things in place, but because it's so convenient, me giving you 20 bucks, right? How many of you guys on the call use Venmo, for example, right? So it's so easy to just give somebody $5, $2. Hey, I can transfer $1.25 because you know what? I split the coffee with you if I wanted to. It just has become more convenient. So there is activity, there is money that comes in where it shows you patterns for drug trafficking. You can find patterns for human trafficking, right? Just go and Google. I don't need to get into the details of how some of these things are found out, but there is tons of information. But at the end of the day, right, what ends up working most of the times is an anomaly detection algorithm, right? Which is not even an algorithm, it's plain statistics. You typically spend $5 at a Starbucks, but this time you spent $100. Okay, is that a problem? Well, it could be, right? Better be alerted to somebody. So most of the times, you use traditional algorithms like, anomaly detection or pattern matching, right? So you might use a k-nearest neighbor to figure out, who is fitting this profile. You might use some clustering to detect, groups that group together. And so many different types of things that you have access to these days that you can use, right? So there is more algorithms out there than problems to solve, right? You can usually just pick more than one algorithm to solve the problem because somebody has done something. And there is, of course, new algorithms that people are coming up and filing patents on and so on and so forth. So I just want to explain, I just want to show you a quick 30-second video of what our software does and how it does what it does. So let me make sure it works here because it's a little bit of an ActiveX control. Ugh. Okay, it's not playing nice. Let me go to YouTube real quick and I will show you a video because this is an interesting video to watch. So let's go to YouTube and all right. Here we, whoops, I didn't mean to do that. There we go.
I feel like you're drowning in data when you're not alone. Meet Adam, a compliance manager for a financial company. If you're like him, you're probably asking yourself, is my data accurate? Is my data complete? Is it AI ready? Well, you no longer have to worry. DataSeers is here to assist you with stress-free decluttering of your data. How do we do it? Firstly, we collect your processor, core bank, and network data. Then we clean, ingest, label, and augment the data.
It looks like we're having problems with the video audio.
All of your information for you.
Oops, hold on.
Provide you the ability to easily access your data, secure, accurate, and complete. Reconciliation, we got you covered. Compliance and fraud detection, of course. Powerful AI algorithms help us detect possible compliance and fraud issues through our full transaction monitoring system. Analytics, that's already built in. As an added layer of protection, we have developed a private distributed ledger. This ledger shares fraud information in real time. Think of it as a watchful community sharing information to increase safety and prevent further fraudulent activity. The best part, you can get all of this from a single data repository. FinanSeer, a unique technology developed by DataSeers. From raw unusable data to actual insights fast.
So,
For more information,
all right. Oops, I'll pause it right there. So you get the point, right? I mean, for those who couldn't hear the audio because the audio was coming out from my computer. I will send the link. Absolutely, yes. I'm seeing some folks asking for the link. So let me quickly switch my screens and go back to my presentation. I'll reshare my screen and then I'll post the link back. So 1 second. All right, so I'm posting the link here. So that's the video link. If you guys go to our channel, which is DataSeers on YouTube, you will see a lot more meaningful content being posted. So what does that bring it to, right? So that brings us to a few more things that we do, right? So remember that if you just developed a software, it's not good enough unless it is production ready, unless it is enterprise ready. What I mean by that is you have to have a fault tolerant system, which means, if one system goes down, one server goes down, you shouldn't be, stuck. HPCC Systems allows us to run this as a clustered, multi-cluster environment. The system has to be secure because of PCI and PII data. The system is scalable, so you can grow and shrink as you want, both on physical hardware as well as on AWS if you guys want, or Azure now. The system is flexible, so you can actually have third-party plugins, web services, so on and so forth. And for the most part, it is a plug-and-play engine, right? So we have various integrations, right? So we have an integration to processors, cores, networks, right? We are working with LexisNexis on the back side. We have APIs. We are doing ACH and wires. We are doing social data engineering. There's so many different things that we are actually doing in our database or in our solution to find the right kind of data that's going to be used for the right algorithm. And it all happens automatically. So with that being said, that's all I had to present. I want to open it up for questions. I know I was supposed to talk for 45 minutes and I'm just 3 minutes shy, which means I can take questions.
Awesome, thank you. For all our attendees, just please put your questions in the Q&A box.
That's a nicer version of me. That's a cleaner version of me. I'm not the COVID-19 version.
All right, it looks like we have our first question. What different types of people work together for security? Like what type of jobs involve like the security of the system?
So I'm not sure I'm following the question. What different people work together for security? Which are you asking me how we secure the information, or are you talking about? I mean, I'm assuming that you're asking me how we secure the information. Is that right, Selena?
From what I'm getting from the question, that does appear to be it.
Okay. So we do a lot of different things, right? So the very first thing about security is the simplest way to do that is first start securing your communications. So you use TLS, you use SSL where applicable, and so on and so forth. Then you start encrypting your data, right? So you don't just encrypt it on the disk, but you can also encrypt it in motion. Generally, people who have access to the systems, right, should be given access on a privileged basis, which means not everybody should have access to everything. So you have to have authentication, of course. You have authorization. You should do two-factor. We do that. We do all of that. We also restrict the roles and the permissions to only show you what you need to see. Further beyond, we also encrypt information on the screen. We encrypt information when it's downloaded. So it's protected at multiple different levels, at multiple different ways. So what type of jobs? Well, it falls under engineering, right? All data engineers and all engineers who are working with the data should know that they need to protect the data. It also falls under security, right? Data security. It falls under data governance to make sure that people have access. If they have access, they're the only ones who should have access, so on and so forth. So I hope I answered that question. So there's one more. Oop, there we go. Are there any open data sets regarding the security you have talked about today to practice with? If you're talking about the sanctions data, which is the OFAC list and all of the stuff, there is tons of data out there. Go to data.gov and you'll be able to download data from data.gov. And if you just Google search any of the data, generally most of this data is openly available as long as it doesn't belong to private, as long as it doesn't contain any private information. So for example, you may not be able to find somebody's social security number on Google, but you may be able to find if they are on a OFAC list or not, right? So all of that data is absolutely available. You can practice with it all day long. All right, what was my educational background, Mr. Anonymous attendee, and what is your current role and what advice do you have for recent computer science graduates who are interested in data science position, internship, or junior level? So I did my bachelor's actually in mechanical engineering in India. I came here, went to school upstate New York, did my master's. I actually was going to do my PhD, but got a job after my master's, so I decided not to pursue my PhD. My master's was very interesting. So although my certificate says mechanical engineering, I worked more closely with the computer science department and with architectural department. My thesis, my PhD thesis that I started writing, but I cut it short and I defended it as a master's thesis, focused on understanding complex data and putting complex data to business use. And what I mean by that back in the day was we were using anthropometric data, which is human body measurements, and we were specifically using it on the on individuals who had cerebral palsy, who are in a wheelchair and cannot necessarily reach out, to understand their reach distance and their grip strength, and then use that data to solve normal problems like how high should a table be, how wide should be a chair, how wide should the aisles be. So if you have ever noticed in a grocery store, the sugar is always kept at the bottommost rung and the lightest items are always kept on the topmost. Why? Because they don't want you to pick that 5 pounds of sugar and drop it in your head, because you may not have the strength to hold it. So this is called as a concept of universal design. It has been around since 2001, since that's when I went to school. And it has been practiced. It is continuously being practiced, and people are putting it to use more and more and more. So there you go. That's my educational background. I always was interested in data. And my current role in this company is to actually build the vision. I work with data science. I'm a hardcore engineer, but my job is actually CEO. So that's why I call myself the chief seer, which means I have to do whatever it takes in order for the company to grow. So I work with junior data scientists, I mentor them. I work with our technology team. I work with our product team. I work with our consumers, customers, and all of that. What advice do I have for a CS graduate who is interested in a data science position? So remember, it's not about algorithms. What you learn in school is almost nothing. When I go, and we hire a lot of people from school. I mean, most of my folks have, we have hired from school. One of my partners in crime or employees, as you say in this business, is actually doing, one of the mentors for the CodeDay, right? She's actually going to be doing some stuff. Her name is Guru. We recruited her fresh from school. She was on her OPT, CPT at the time. We got her visa done, and she is right now the number 2 in the company. She runs everything after me, right? So that's a pretty good track record for somebody who has just been working with us for 2.5 years. So what we look for is smart people. I don't care what courses you did. I don't care how much you know. If you're smart, and if you are hardworking, and if you are going to, you're almost in a data business, You have to have OCD. You have to have attention to detail. You need to look at every little thing, leave no stone unturned. So one of the biggest quality that I don't recruit is somebody who gives up too easily, right? You can't give up. You know, you need to ask the why. Why. I mean, that's the best quality you can have, right? So Arjuna has asked, what type of jobs can a college student apply for at DataSeers? So we have various job positions that we advertise throughout, right? So we have, internships. We have ETL developers who are just focusing on transforming the data. And there is no shame, right? So I will tell you this funny thing. People use the term, I'm a data scientist. I have spoken to some data scientists and they're doing nothing but just looking at data all day long, right? So that's not a data scientist for me, to be very honest, right? So for us, data scientist is actually a guy who is constantly creating new ways to solve the problems using data, computer science, and engineering, right? So that's what data science really means to me. That's not what the world today talks about data science, right? So if you're doing anything remotely in data, calling yourself a data scientist is considered super cool these days. But it's much more involved. I would say this, right? I don't even think our company has a single data scientist, right? These are just data junkies. They just love data. I mean, a company like LexisNexis would have data scientists because they are the ones who developed HPCC Systems. They came up with a data engine. They came up with all of these algorithms that they wrote. So that's what data science is about, right? But there is a more practical application of data science, which is what is in our company. And yes, we do have data scientists, don't get me wrong, but they are more playing with the data, combining it differently, creating some things. There is more engineering, right, behind that, and art than anything else, right? What features to use, and you require a lot of domain expertise for that. All right, do you guys have any other questions?
We can just give the attendees like one more minute.
Yeah, and if you have more questions, I can easily be found on the internet. I'm on Twitter, I'm on LinkedIn. It's not difficult to find me or our company. We are out there. So if you have any questions later on, feel free to tweet it to me. My Twitter handle is AA Joshi. So you can just tweet it to me, or you can send me a LinkedIn question, because when I was in college, I used to be very shy. I did not ask a lot of questions. I used to be the guy that sat on the last bench and never uttered a word. So there are some people I know, they get very shy asking questions. Are we hiring now? We are. We actually are hiring right now for various different positions. In fact, I was just posting something on LinkedIn about us currently recruiting.
Well, that looks just about it for the questions. I want to thank you so much for coming. It was awesome to have you here and give this amazing talk. So thank you.
No problem.
All right. Goodbye, everyone.
Thank you. Bye.